creamy orange color. Yellow. Red. Pink. Purple. White. The colors of flowers are nominal level measures. They're just words. You can't say there's an order to the flower colors, so they're just words. Nominal level data is words only. Nominal level data is qualitative data. Qualitative also refers to just words, and it's discrete in the sense that there are certain color words. Purplish pink, lavender maybe. But you can't really talk about fractional colors. That doesn't make any sense. Another level of discrete is ordinal. At the ordinal level, we might have words. Words such as small. Oh, right down there. That's Pilea microphylla. That's a very small plant. It never gets very big. Then, of course, there's shrubs, such as a hibiscus shrub. There are small trees, such as a lime. And there are larger trees, such as that palm. So we have, in the world of plants, we have small herbaceous plants like that. We have shrubs, and then we have trees. We can put the words in an order from smallest to largest. We still can't talk about fractions, but there's an order, there's an inherent order in which you can put the plants. And so we can speak of plant order, and we can talk about the data as being qualitative, it's words, but the words have an order, small, medium, large, from a little herbaceous plant to a shrub, up all the way to a large tree. The next level is the first of the numeric levels, interval. At the interval level, we might be counting the number of green pepper plants we have. Now, the number of plants we have, we'd simply count as 1, 2, 3 plants. You wouldn't hear somebody say, well, I have 3.5 plants. That doesn't make any sense. What's half a plant? Half a plant is still a plant, isn't it? I mean, there are many plants which you can simply whack at, trim and cut, and they grow right back. Plants such as the Vulcamaria nermis back here, and right next to it, the gardenia, the Vulcamaria nermis here, the allow. You can cut it all the way back to the bottom and it will grow right back. There's no such thing as a half a plant. This is still numeric. We can count 1 plant, 2 plants, 3 plants, 4, but it's got no fractions. That's interval level data. It's quantitative, which means you're counting numbers, but it's whole numbers. And we don't have any fractions. There's no fractional values. It doesn't make any sense to talk about a fractional value. If somebody says, well, how many orchids do you have? Well, I have 2.25 orchids. Well, there's no such thing as 2.25. That's interval level measurement. The last one is ratio level measurement. At the ratio level of measurement, we're usually talking about numbers, always numbers, and usually numbers that we can measure. And so, for example, this leaf, hold on, here we go, this leaf, that leaf there is about really close to 13.652, no, 13.72349911803 centimeters long. Okay, I'm just making up all those extra digits, but that's the point. The measurement is only limited by the accuracy of my measuring tool. If I get a better tool, I'll get a more accurate measurement. And there's fractions. I can talk about 13.5 centimeters, 14.5. So at the ratio level, we're dealing with numbers. And the numbers have fractions that have a meaning. We can talk about somebody having a mass of 67.5 kilograms or a weight of 143.5 pounds. We can discuss numbers with fractions. That's ratio level measurement. That's a quantitative level. It's the one level and the only level that's continuous. All the other levels are discrete. Pink, you can count the colors. So it's discrete. There's separate colors. That's purple. Only the ratio level is continuous. And by continuous, we mean that there's a continuous gradient, as I showed you with the last leaf. Here another leaf on an ixora. There's a continuous gradient of sizes available with fractions. There's an infinite number of lengths possible, depending on how good our measurement tool is. So that's perhaps a second look at qualitative, words, quantitative, numbers, discrete, things we can count, continuous, things we measure and probably cannot count because there's an infinite number of possibilities, and the nominal, ordinal, interval, and ratio levels of measurement.